For this problem, it's going to give us a system of inequalities instead of equations. And actually, it's going to be 3 inequalities. And we have to graph it and figure out the best situation. So it says 2 manufacturing plants make the same kind of bicycle. The table gives the hours of general labor, machine time, and the technical labor required to make one bicycle in each plant. For the 2 plants combined, the manufacturer can afford to use up to 4,000 hours of general labor. So if it's up to 4,000 hours, it can't be over that. So it can be up to, so it can be equal to, but it can't go over. So less than or equal to 4,000. Now it says up to 1,500 hours of machine time. So again, less than or equal to 1,500. And up to 2,300 hours of technical labor. So 2,300. It says Plant A earns a profit of $60 per bicycle, and Plant B earns a profit of $50 per bicycle. So if we're trying to make a profit inequality, if it's talking about Plant A or Plant B, well, Plant A makes a profit of $60, and Plant B makes a profit on each bike of $50. How many bicycles per week should the manufacturer make in each plant to maximize the profit? So, if you go over here in the box, your 3 inequalities, just going strictly off of the chart, which it already gives you your variables for x and y. I'm just going to go ahead and write them down. So we have 10x plus 1y. I'm just going to write y has to be less than or equal to 4,000. And then we have 1x, or just x, plus 3y. Has to be less than or equal to 1,500. And your last inequality is 5x plus 2y. Has to be less than or equal to 2,300. And then that profit equation that we came up with, I'm just going to do P as profit. So 60x plus 50y. We want to reach our profit or make more than our profit. So whatever that value is, our $60 for the bikes at Plant A plus our $50 for our profit on bikes from Plant B, we want that to be greater than or at least equal to our profit. So if we rearrange these, and I've already done this, so I'm not going to show the steps, but if we rearrange these to try to get y, because if you guys see that graph below there, we're going to have to graph these. So in order to graph them, we need them in the slope-intercept form, which means we need y by itself. So the first one's pretty easy. We end up with y is going to be less than or equal to negative 10x when we subtract that over, plus the 4,000. Our second one, when we rearrange it, we have to subtract that x and then divide everything by 3. So 1x divided by 3 will give us 1/3 x, but we subtracted it over, so it's negative. And then plus 500 because 1500 divided by 3. And lastly, subtract the 5x over and then divide everything by 2. So 2 divided by 5, so we will get negative 2/5, or I'm sorry, negative 5/2 x, and 2300 divided by 2 is 1150 or 1150. So those are going to be our 3 inequalities for us to graph. And I'm going to just flip to a new slide in order to graph those. So now that we have our graph here, and you guys should have it on your notes, I'm going to graph each one of these. So y is less than or equal to negative 10x plus 4,000 is tricky because we don't have 4,000 on our y-axis. So if we're looking at that, what I decided to do is, instead of finding my y-intercept, I decided to find my x-intercept. So if I plug in 0 for y and solve for x, I would subtract the 4,000 over and then divide 4,000 by 10. And you get 400. So that is our x-intercept. So 100, 200, 300, 400. And your slope's still going to be down 10, right 1, or up 10, left 1, if you guys can't go down any further. So if we did that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and it's going to be way up here. And that'll be your first inequality. Again, I'm trying to make these lines as straight as I can, but you guys should be able to do a little better on your paper. All right, second one, y is less than or equal to negative 1/3 x plus 500. That one we do have a y-intercept we can graph, and the slope is down 1 over 3. Down 1 over 3. And your last inequality, y is less than or equal to negative 5/2 plus 1150. So 1150 is up there pretty high. So again, I would plug in my x value, or plug in my y value of 0 to get my x value. So if I did that, I would subtract the 1150 over and get negative 1150 is less than or equal to negative 5/2 x. So if you multiply both sides then by the reciprocal, you would get x has to be greater than or equal to, it looks like 460. So 460 would be right around there. So our slope for this one is rise 5 over 2, and it's negative. So 1, 2, 3, 4, 5, 1, 2. And again, try to draw it as straight as you can. Now, if we're trying to find the most profit, if I shade these, so let's shade it in gray. Everything is less than, so it's going to be shaded below. So what you guys want to look for, all the solutions, is everything that's shaded, but specifically where your inequalities are intersecting because those are the highest values that we can get. All the borders, all the points on the borders are the highest values we can get. So if we're looking at this, our intersecting points are all the corners, essentially. So if we found those ordered pairs, so it looks like 0, 500. We, of course, have 0, 0, but that's going to get us no profit, so we probably don't want that. It looks like 400 and 300, so, and I said that backwards, 300, 400, and again, these are hours that we're talking about. And then 380 maybe, and 0, or nope, I'm sorry, 400 and 0. 380 and about 220. So if you're looking at all those intersecting points, what you can do is plug each one in and see which one gives you the highest profit in these inequalities. So if you're going back and looking at that profit equation, and I'm running out of space, if you plug it into your profit inequality, which was profit should be no less than or equal to 60x plus 50y. If you plug each of those ordered pairs in, you could see which one gives you the most profit. And I did do that. And I also know that the point that's going to be the farthest to the right and the highest up, averaged out, is going to be the one that's going to give you the highest profit. So your highest profit is going to be here. So if we have 300 hours from plant A and 400 hours from plant B, that's going to give us our highest profit. So plant A is 300 hours and plant B 400 hours because plant B was Y. So we wrote our inequalities, we graphed our inequalities, and then we looked at our intersecting points and said, okay, based off those intersecting points around the border, which ordered pair or solution is going to give us the highest profit? And that's how we came up with the ordered pair, 300, 400. 300 hours from plant A and 400 hours from plant B is going to give us the highest profit on these bicycles. Now, with that being said, go ahead and try example number 4 on that one back page. I understand it says do not graph them, but guys, it is fine if you need to graph them. You don't necessarily need to because in this case there's only 2 inequalities. You can just solve for it as though it were an equation instead of an inequality and use like your substitution or elimination, whatever you prefer. But you can also just graph it too. That's absolutely fine, even though it says do not graph it. I'm not going to be a stickler about it. So go ahead and good luck.